Welcome to the Astro Guy podcast. I'm not an expert, I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem, seize the night. Welcome to a special edition of the Astro Guy podcast. I'm your host, Wayne Zuhl, and there's some fun and interesting things going on in the sky in the near future. In this episode, we'll talk about the ABCs of Stargazing, library telescopes, and what could be a very nice comet, Comet Leonard. Recently, on the Astro Guy podcast Facebook group, there was a post titled The ABCs of Stargazing. This document, published by the Astronomical League, is a great reference for beginning stargazers as well as seasoned amateurs. I urge you to go to the Facebook page and take a look at it. The document was designed to be distributed with library telescopes. More on that in a few minutes. Each month when I talk about what's up in the sky, I will often reference those ABCs. So I felt that it was important to spend some time defining exactly what those ABCs are. Let's start at A. A is for angular size. They never said that on Sesame Street, did they? Often, I will refer to an object in degrees, as in degrees of arc. If you were on a mountaintop and had a clear horizon in every direction, you could point your finger at the eastern horizon. And if you moved your arm to point your finger at a point directly over your head, you'd have moved your arm 90 degrees. So the sky spans 180 degrees from horizon to horizon. It's a simple concept, but it can be hard to visualize. The moon is about half a degree of arc across to any observer on Earth. So knowing that the sky is 180 degrees across, it would take 360 full moons lined up end to end to make a line of moons going from one side of the horizon to the other. Let's break it down even further. If you make a fist and then extend your index finger out and hold it at arm's length, the width of your index finger at that distance is about 2 degrees. If you close your fist, the width of it at arm's length is about 10 degrees. Another method for larger angles is to spread your fingers as wide as they'll go, and then at arm's length the distance from the tip of your thumb to the tip of your pinky is about 25 degrees. The Big Dipper, an asterism in the constellation Ursa Major, is a helpful tool to find Polaris, the pole star in the northern hemisphere. The pointer stars Merak and Dubhe are the two stars that make up the bowl on the end furthest from the handle. If you follow those stars in a line for 30 degrees, you'll be at Polaris. The Big Dipper itself is helpful in getting a feel for angular distance. Merak and Dubhe, the pointer stars, are 5 degrees apart from each other. The distance from Dubhe to Megrez, the two stars that form the top of the bowl of the Dipper, are 10 degrees apart. So hopefully this will help you get a feel for measuring angular degrees in the sky. In the future, we'll break this down even further, but this should be a good start for now. Moving to B in the ABCs, we refer to brightness. In astronomy, we use the magnitude scale to describe how bright an object is. The scale goes from extremely faint with a very high number to the brightness of the sun at magnitude minus 26. Please never, ever look at the sun without using a proper solar filter, even with the naked eye. You can cause permanent damage to your eyes in a very short time, and never look at the sun with binoculars or a telescope unless there is an approved quality solar filter covering the objective. Okay, enough of the don't look at the sun part of this. Just remember that the brighter the object is, the smaller its magnitude will be, and objects with a negative number for their magnitude are very bright. So we know that for us, the sun shines at magnitude minus 26. The full moon shines at magnitude minus 12. Venus can be as bright as minus 4.9, while Jupiter at its brightest is about magnitude minus 2.5. The brightest star in the night sky is Sirius, the dog star, in the constellation Canis Major. Sirius shines at magnitude minus 1.5. Some stars that are nearly magnitude 0 are Arcturus at minus 0.05. Capella and Rigel are just barely into the positive, ranging from 0.03 to Vega to 0.13 for Rigel. Capella is right in the middle at magnitude 0.08. The star Pollux in Gemini is first magnitude. Polaris in Ursa Minor is magnitude 2. The faintest stars that you can see with your naked eye are a little fainter than 6th magnitude, but that is assuming you have excellent vision and you are under extremely dark skies with little or no light pollution. Using 50mm binoculars, well-practiced observers under dark skies can spot stars as faint as 11th magnitude. With a 10-inch telescope, meaning the objective lens or primary mirror is 10 inches in diameter, under excellent conditions, you could spot stars as faint as 14th magnitude. The larger the telescope, the fainter the stars that you'll be able to see. So hopefully this makes the magnitude scale a little bit easier to understand. Moving on to the C's in the ABCs, the C stands for coordinates. On Earth, we use latitude and longitude to define a point on the surface of the Earth. In the sky, we use a similar system. Right ascension is similar to latitude and declination is similar to longitude. Right ascension and declination are the coordinates that we use to reference objects on the celestial sphere. We also sometimes refer to altitude and azimuth. These are measures that are in relation to the observer. So if someone in New Jersey were looking at an object at a specific date and time, an observer in Florida looking at the same date and time would have different altitude and azimuth coordinates for the same exact object, even though both observers would be looking at the same right ascension and declination. I know it sounds confusing, but once you grasp the concept, it's pretty simple to understand. Hopefully, this helps you get a clearer understanding of the ABCs of stargazing. I promise that with practice, these terms will become easier to understand and to use. Earlier in the episode, I mentioned library telescopes. This was a project that originated in New Hampshire by a group of dedicated amateur astronomers who wanted to make the hobby a little more accessible to everyone. The project expanded, and there are now library telescopes in 45 of the 50 states. Telescopes can be expensive, and many people may not have the budget to spend several hundred or even thousands of dollars to purchase a telescope. Worse, oftentimes a beginner may buy a telescope that is beyond his or her understanding of how to use it, and after failing, they'll give up, losing out on one of the greatest treasures we have, exploring the night sky. So the library telescope program was created to make telescopes accessible to library patrons to borrow them just like they would a book. The telescopes used are Orion Star Blast telescopes. They're 4.5-inch reflectors that have been modified so that they can take the wear and They're 4.5-inch reflectors that have been modified so that they can take the wear and tear of constant use. If you live in Clark, Fanwood, Scotch Plains, or Linden, New Jersey, and you're a member of the library, you can borrow one. For more information on the program or to see if there's a library with a telescope near you, visit librarytelescope.org. Moving on to Comet Leonard. In the summer of 2020, many of us were able to witness Comet Neowise gracing the skies. Comet Neowise was one of the brightest comets to be visible in many years. Comets are extremely unpredictable. Sometimes they'll quickly brighten, and other times they'll just fade unpredictably. Some comets have even broken up into several smaller comets due to strong gravitational interactions with the gas giants or the Sun. So what exactly is a comet? Comets have been described as dirty snowballs, but in reality they are made up of water ice, dust, and rocks. When they are far from the Sun, these frozen bodies can range from a few miles across to dozens or even hundreds of miles across. Relatively small in astronomical terms. But as they make their way toward the inner solar system and experience solar radiation, they begin to spew gas and dust into a tail that always points away from the Sun. A comet's tail can extend for millions of miles. Comets themselves are leftover matter from the creation of our solar system. There are estimates that there are billions of comets orbiting the Sun in the Kuiper Belt and even further out in the Oort cloud. Currently, there are 3,743 known comets, meaning ones that have been discovered by humans. In early January of 2021, senior research specialist Greg Leonard discovered comet C/2021A1, now known as Comet Leonard. Astronomers have calculated that Comet Leonard has been orbiting the Sun for more than 35,000 years. Its furthest point from the Sun, known as aphelion, is at a distance of 35,000 astronomical units. 1 astronomical unit, or AU, is the average distance of the Earth from the Sun, about 93 million miles. So at aphelion, this comet was about 3.25 trillion miles from the Sun. That's nearly half a light year away. But now, the comet is headed toward its closest approach to the Sun, which will take place exactly 1 year to the day from its discovery. Its perihelion, or closest approach to the Sun, occurs on January 3rd, 2022. Comet Leonard will fly past the Sun at a distance of 0.62 AUs. On December 12th, 2021, Comet Leonard will make its closest approach to the Earth at a distance of a mere 21.7 million miles. How can you see it? What will it look like? Well, as I'm recording this, Comet Leonard is currently at magnitude 12.8, and it's already got a tail that's about 5 arc minutes long. That's faint and small right now, but it's still about 8 weeks from its closest approach to the Earth. Predictions are that by the beginning of November, the comet will have brightened to about 10th magnitude, and it should be visible in a 6-inch telescope. By the end of November, it should be about 7th magnitude, and be easy to spot in 50mm binoculars. On December 2nd and 3rd, the comet will pass by the globular cluster M3 in Canis Venatici. On December 6th, the comet will be at around magnitude 5.5, just visible to the naked eye under very dark skies, and it will be about 5 degrees away from the magnitude 0 star, Arcturus, in the constellation Bootes. As the comet continues to near the Earth, it will be low in the southwestern sky in the early morning. On the morning of the 12th of December, moonlight will not interfere, and the comet should be a lovely spectacle if you have a low horizon to the southwest. As the month continues on, the comet will continue to head south before fading from view. There is a possibility that the comet may brighten substantially. Some astronomers are predicting that it could get as bright as 1st magnitude by December 12th. With brighter comets, I usually try to spot them with 7x50 binoculars. I also use a 70mm refracting telescope at low power to give an even better view of the comet. If you want to try to image the comet, you can do so with just a camera and a tripod. Use the 500 rule to figure out how long you can expose the sensor before the stars will trail. To do this, just Google 500 rule calculator, enter your camera's specs, and it will tell you how many seconds you can open the shutter before the stars will trail. I would recommend using a fast, low f-ratio, wide field lens, as this will give you more exposure time and a better likelihood that you'll get the comet in your image. We would love to hear about your successes in viewing and imaging Comet Leonard. Feel free to share them on our Facebook page. So go out and enjoy the night sky. That's all for this mini episode. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy podcast group on Facebook. You'll find other members' posts, videos, blogs, and other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Thank you again for listening, and may your skies be clear. As always, Carpe Noctem, seize the night. I'm Wayne Zool, and this is the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. You can reach us at astroguypodcast@gmail.com. Please join our Facebook group at facebook.com/groups/astroguypod. Keep wondering, keep your eyes on the sky, have fun. Carpe Noctem, seize the night.